Good morning, good afternoon, good evening, wherever you are. I hope you're doing great. Thanks for joining me today. Here's what we're going to be working on today. We are working on translations and reflections, and I'm going to explain specifically what both of those mean in just a little bit, and then we're going to examine how these can play out within the coordinate plane more or less. And so here's what I want you to do. I'm going to read off the blanks here. For numbers 1 through 6 for the key terms, and maybe I'll explain a little bit more as we're going along, but I need you to fill this in so that you can get a better understanding of where we're headed for today. So number 1, it says a transformation. So that first blank is a transformation of a geometric figure is a function or mapping that results in a change of position, shape, or size of a figure. Anyways, sorry about that. I just was interrupted by the janitor. Being a child of the 80s, when I look at the word transformation, my first thought goes towards the Transformers. Okay, I don't know if any of you guys have seen the movies of Transformers. You know, Optimus Prime, the Decepticons, Bumblebee, all those. But you have something that looks like an object. In the case of the Transformers, it looks like a semi or a car, and it transforms into something completely different, okay? Now, in most cases of what we're going to be looking at, it's not going to transform into something completely different. We looked at dilations earlier on this year, and dilations that can be bigger or smaller. They're similar in size, but the ones that we're going to be looking at today and tomorrow, they won't change in shape, okay? It's going to be the exact same shape. They're going to be congruent. So next sentence, over the next 3 days, we will be looking at different types of transformations. So that next blank is transformations. Today we'll be working on translations and reflections, obviously by the title of the packet here. And tomorrow we'll be working on rotations. And the next day we'll be working on dilations. Now, differing years, I may do this out of order, and so this year I chose to do dilations earlier when we were doing similar figures. So when I originally typed up this packet, that's the order that I was going to do it in. These next two terms, actually these next couple of terms are all really key. In a transformation, the original figure is the pre-image, okay? And so where you're coming from, think prehistoric, where you came from, that's the before, and then after the move, after the transformation, okay, the resulting figure, number 3, after the transformation is called the image. So where it was before, the original is the pre-image, and where it is now is the actual image. And so those two terms will be used quite often. So understand, before is the pre, after is the image. Number 4, transformation that preserves congruency is either called rigid motion, okay? And so I guess when I think of rigid, someone that's rigid in movement, when we think of athletes, the opposite of fluid, okay, is someone that moves smoothly, is flexible, and can change in position easily, would be rigid, okay? And someone that's rigid is tight and can't change very well, okay? So when we think of not changing in shape, think rigid, okay? It's tight, it doesn't change in shape, it's not fluid. Rigid motion, or is called a form of isometry, okay? Now, isometry is a little more technical term. When we were taking the park tests a couple years ago, we were getting prepared for that, and the term was rigid motion, okay? So you need to know really both terms. Isometry is more technical, and rigid motion. Number 5, a translation, that blank is translation, is a glide or slide of a point or set of points in the same distance and same direction. Okay, and I'm going to explain a little bit more of that here in a second, but that's a translation. And a reflection is exactly what you think of when you think of reflecting something. Okay, a reflection is a flip across a line of reflection. Okay, so those two blanks, line of reflection. And I want you to circle the next word, the perpendicular. I want you to circle that. The perpendicular distance from the preimage to the line of reflection must be congruent to the distance of the image to the line of reflection. And again, I will do a better job of explaining that because that's kind of a technical sentence there, but it is very, very important. All right, so here's what we're going to do. We're going to start with translations, and we're going to move to reflections. And I think you're going to find translations very, very simple. So in looking at, let's see if I can get this off. Here we go. In looking at the first problem here, I want you to go ahead and graph those first 3 points for me. So make this a little bit bigger. Okay, go ahead and graph those first 3 points and connect them for me. Actually, you know what? Okay. A, negative 2, 1, 2, 3, 4, 5. And B is going to be at 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. That's B. And C is at 1, 2. Okay. And so once you've graphed that, what we're going to do is we are going to move this figure 4 units right and 7 units down. And so this is the preimage, okay? 4 units right, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. This is where the actual image is going to lie. And so I'm going to put down an A, and it's going to be A prime. When you move a figure one time, we usually put a prime on it to show that it's no longer that same image, it's been moved in some manner. Okay, and we're going to do that same thing for all 4 of them, or for all 3 points. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Okay. All right, and so as we look at the 2 shapes that have been formed here, see if I can get this off. There we go. The 2 shapes have been formed there. I hope what you can recognize and see, especially if you did this with a straight edge, and I probably should have, but I wanted to save time. It's the same exact shape. I haven't changed it in any manner. It's the same shape. They're both congruent to each other. So this would be a form of rigid motion, as I talked about just a second ago. Now, I want you to understand there's something that's being played out here. And so as we look at the preimage to the image, I want to go ahead and graph or write down the actual ordered pairs here. So A is going to be at 2, negative 2. So let's go ahead and put that down. 2, negative 2. B is out here at 10, 11, 1. 11, 1. And then C is over here at 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we have 5, negative 5. Okay. Now what is it about these 3 points with respect to the preimage's 3 points that I want you to see? Well, maybe you already see this, but if I go ahead and take the original point, and then if I am going right 4 units, we're thinking plus 4. If I can write that down, that looks pretty. Plus 4, and over here we're thinking down 7, we should be thinking negative 7. Okay, so if I add 4 to negative 2, that gives you a positive 2. And if I subtract 7 from 5, that gives you negative 2. Okay? Let's do the same thing to this one and see if it holds true. We have plus 4. Well, that's 11. That's good. And we're thinking minus 7. Well, that's 1. We get the same thing there. Okay? So let's just for argument's sake, finish this up. If I take 1 plus 4, does that give me the x value over here? It does. And if I take 2 minus 7, does that give me the x value over there? It does. So, there's really two ways of going about this problem right now. One, you can go ahead and you can, graph it out and label the points and find the new ordered pairs. Or you can go ahead and just calculate it out like I did in the middle there. All right? Now, excuse me. Excuse me. Got a cold coming on. All right, now, from there, let's go ahead and do this. What's the rule that's being formed? Well, the first one I'm going to write down is the most important one. I've seen two different ways to write the rule down. This first one is the most important because I think it's the most, it's the one that's going to be used in most standardized tests these days. And so, if you have the original x, y, when they write a new rule, they want to know what happened to that x, y. Well, if we look up here, we added 4 to each of the x's, so x plus 4, comma, and when we do the y's, we subtracted 7 from the y's, so y minus 7 would be the rule of that first one, okay? Now, another way to write this out that I've seen in a different textbook is to actually say, okay, I'm working with a translation, so a T, okay, and then they will go ahead and say something like this, 4 negative 7, that 7 was sloppy, sorry, and then we're talking about the figure that we're working with, so in this case it'd be triangle ABC, okay. So again, they're showing you what you want to translate and what figure you want to translate when writing it out like that, okay. But of the two, I want you to definitely know how to write this one out for me, okay? Now, what I want you to do is I'd like you to pause the computer and go and do the next example. It's kind of the same, but in this time, I'm giving you the pre-images ordered pair and I'm giving you the images ordered pair, and I want you to tell me what the translation is going to be. So take a moment and go and graph those out for me, and then come back and we'll talk about what you did. So. All right, so I know that this problem is a little bit different than the last one. Hopefully you at least were able to get this all graphed out for yourself. But here's what I want you to see. In order to figure out how far a figure has been translated and in what direction, you need to have the two figures labeled out. Now remember, this right here is the pre-image. This right here is the image. And so as I look at these two shapes, what I need to ask myself is, I need to pick out the same point on both structures. So if I pick out point P here, and pick out P prime here, the question is, how far did P go to get to P prime? Oh, or S to S prime, Q to Q prime, or R to R prime. And so as I do this, the X value always goes horizontally, Y value always goes vertically. So if I do this 1, 2, 3, 4, 5, 6, 7, 8, I'm advancing 8 to the right. Okay. And I'm going 1, 2 down, okay? Now, probably a good thing at this point is just to make sure that that holds true for at least another point or two, just to make sure I've got it. Now, you don't want to go from Q to S, you want to go from Q prime to S prime. So if I count this, 1, 2, 3, 4, 5, 6, 7, 8 to the right, and 2 down. I got the same thing. Let's go from R to R prime just to make sure. 1, 2, 3, 4, 5, 6, 7, 8, down 2. Okay, so we've got the rule. Now from there, I want to write out the rule. So one way to write it out would be to go ahead and say, okay, here's my original pre-image. And what did I do? Well, I went 8 right and 2 down, okay? Now, something I didn't think about when I was making out this sheet is that my first two examples go right and down, all right? And so let's think about this for a second. What if I were to go, let's say, left and up in two different directions there? Well, if you go left and up, obviously your x value is going negative because I'm going to the left, and your y value is going positive because you're going up. So make sure that you understand your way around the coordinate plane and what left and right, positive and negative. Left would be negative, right would be positive, up would be positive, down would be negative. Make sure you understand those two, or those four. Now, the other thing is, the other way to write this, the translation of this, well, I'm moving 8 and down 2, 8 right, down 2, and then what am I moving? I'm moving the quadrilateral PQRS. So that's just another way to write it. Again, we really need to know how to write it according to the rule in the first section there. So just keep that in mind. So here's what I want you to do from here. You've got about 4 examples on the back side that I'd like you to take a moment and go ahead and work through, okay? And see if you can answer those 4 questions for me. Now, granted, the 4th one is kind of a challenge problem, okay? And so I just want to see if you can do that. When you're done with that, come back and join me, and we'll be talking about reflections. All right? All right. I misspoke when I originally said that there were only 4 problems. There were actually 8 practice problems there, and so hopefully you got a chance to look at all of those practice problems. As I was just looking over them, obviously number 4 was a little bit of a challenge problem, and then 7 and 8 are more of your real life examples of a translation. But I think if you map those out on a piece of paper, you can figure those out pretty easily. And so, moving on to reflections, if you haven't already, you want to graph the triangle ABC, and within this graph, we're going to reflect triangle ABC across the y-axis first, okay, to form triangle A prime, B prime, C prime. And so when I reflect that across the y-axis, okay, obviously this is the y-axis right here. And if you remember back on page 1, the key term number 6, I want to bring this to your attention again. It says a reflection is a flip across a line called the line of reflection. In this first part, this is the line of reflection, the y-axis, okay? And then it says the perpendicular distance from the pre-image to the line of reflection must be congruent to the distance of the image to the line of reflection. So I know that was a mouthful, but here's what I want you to understand. If I count this distance from here to here, the line of reflection, that's 1 unit over. Now you'll notice that that's a perpendicular distance, perpendicular to the line of reflection. So 1 unit over, and I go 1 unit on the other side, there's where C prime will lie, okay? If I do the same thing with A, 1, 2, 3, 4, okay, that's the distance from A to the line of reflection, perpendicular distance, 1, 2, 3, 4. I put down my point, and that will be A prime, okay? And then B, 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just a reflection on the other side, okay? So as we go ahead and take a look at this, all right, one thing I hope that you recognize is that those 2 shapes are the exact same. So what do we call those shapes? Well, it's an example of rigid motion or isometry, all right? And so there's actually a rule that can be formed from this. So if I go left 1 and up 3, that would be -1 for C, 3, okay? If I do A, this would be -1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, -4, 7. Okay, so if I look at the examples here, 1, 3, -1, 3, 4, 7, -4, 7, we can make a guess as to what B prime is going to be. I'm going to say -1 or -9, +4. So let's see here. -1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. That's exactly right, -9, 4. So what's the rule here? Well, if you think about it, if we are taking -4 and we're becoming negative, if we're taking +4 and we're becoming -4, all I'm doing is taking that x value multiplying it by -1. Is anything happening to the y value? No, so just multiplying it by +1, okay? Same thing with this one. 9 times -1 gives me -9. 4 stays the same, okay? And so the last one, 1 times -1, 3 stays the same. And so what's the rule that we're going to write out? Well, we have the original preimage, and that becomes, okay, you can put -x, -1x, but it's got to be the negative of the x, comma y right there, okay? And so that's an example going from the reflection of the y-axis preimage to image. All right, now the next one, it says, then reflect ABC, the original preimage triangle, ABC, across the x-axis to form A double prime, B double prime, and C double prime. See if you can come up with the rule for making a reflection across the x and y axes. So if I do it across the x-axis, the perpendicular distance is going to be straight up and down, okay? So 1, 2, 3, 1, 2, 3. There's C double prime. A, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There's A double prime. B, 1, 2, 3, 4. 1, 2, 3, 4. Okay. There we go. Again, if you just look at the two shapes, I realize I freehand drew them, which kind of changes them a bit, but I hope you can see that they're congruent to each other. It's a form of rigid motion. So if I figure out C double prime, 1, -3. And some of you may be looking for the rule already, which is a good thing. A is going to be over here at 1, 2, 3, 4. -1, 2, 3, 4, 5, 6, 7. So 4, -7. Okay, and so B prime, let's just make a guess here. 9, I'm going to say it's -4. Let's see if that's right. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4. We're exactly right. Okay? And so some of you may have already filled in the rule down there, but what we're looking at here is the 4, the x value staying the same, and then the y value is the one that's flipping signs. Okay? The x value is staying the same. The y value is changing signs. All right? And the same thing with the last one. All right, so the rule that we're looking at here, okay, the preimage, how does it change? Well, this time instead of the x value becoming the negative like it did here when we're flipping across the y-axis, this time the y value became negative, okay? And so it's kind of counterintuitive to think that way. You're flipping across the y, so the x values change. You're flipping across the x's, so the y values change. But that's exactly how it plays out, okay? All right, I want you to go to the next problem, and I want you to go ahead and graph the triangle DEF, and then I want you to draw on the line y equals x, if you can remember how to do that, okay? And then we're going to talk about how to reflect that across that line right there. So take a moment and go ahead and do that for me. All right, so I went ahead and graphed the graph of triangle DEF, and hopefully you've graphed that one out correctly also. And then what I'm going to do is I'm going to graph the line y equals x. Now remember, y equals x in slope-intercept form, there's some parts that are missing. They're there, but you just can't see them. The slope is 1 over 1, and the y-intercept is 0, okay? And so if I go ahead and graph this line right here, we're going to start at 0, 0. Okay, right there, that's the y-intercept. And then from there, I'm going to graph a slope of 1, up 1 over 1. Now, up 1 over 1, up 1 over 1, I think you can see that I'm graphing that slope. So this line will look just like that right there, okay? And so how do I graph this reflection? Well, remember what we talked about back in the key term number 6, that statement there. It has to be a perpendicular distance and then equal distance on both sides. So if you remember back, I don't know if it's chapter 3 or chapter 4, if your slope is 1 over 1, what's the perpendicular? Question, perpendicular slope. Well, remember, it's the opposite reciprocal. So the opposite of 1 is negative 1, and the reciprocal 1 is still 1. So we're looking at negative 1 over 1. So I have to go ahead and use this opposite slope. So if I do that, a negative 1 slope will rise and run like this, okay? So one way of doing this is to count this. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there is where my point for D prime will have to lie. Okay, and you can see that if I were to draw a line connecting those dots right there on the bottom side, that would be a perpendicular line to the line that's already there. Okay, so if I do the same thing with the other 2 points here, I can go ahead and count 1, 1. Right there, that's F prime. Okay, counting this one, E, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. E prime. That's kind of a nasty prime there. There you go. Okay. So we've got this triangle here. And again, what I'm hoping you're going to see is that this reflecting figure is a form of rigid motion. All right? I have not changed my shape in any way. The 2 figures are still congruent. Okay? Which is why when we want to see a decently accurate depiction of ourselves, we look in the mirror. We want to see a reflection to see how we look, if we change anything before we go out and do anything. Now, there is another way to go ahead and do this perpendicular distance that some of you may find easier, and that is just to do this. If I just count the diagonal distance here. So if I do this, 1, 2, 3, 4, and a half, 1, 2, 3, 4. Here, I have a half and a half. Okay. Here I have 1, 2, 3, 4, 5, 6. Did I count that right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So yeah, you see it there. That it's another way you could do it. Same thing. Okay. Now let's actually go ahead and map out these points here. For D, actually let's do F. Well, let's do D first. Negative 2, 1, 2, 3, 4, 5, 6, 7. Negative 2, 7. Now I'm hoping that you guys are already starting to think in your minds, ooh, I see a relationship there. I see a pattern. Let's see if that pattern holds true for, let's say, F. Negative 2, negative 1. So as you look at that, it looks to me like we're flipping the x and the y. Well, let's flip the x and the y here and see if it's the exact same. Negative 8, positive 4. So if I do that, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. We're exactly right, negative 8, positive 4. So what are we doing here? I'm not going to write anything up here to show what the rule is, but I hope that you recognize the original, ignore this over here, that was a mistake, the original pre-image, okay, to the image, we are going to flip-flop the x and the y. Okay, and that's a reflection across the line y equals x. Okay, all right, so I've got one last example here. I think it's my last example. Yeah, my last example. I'd like you to go ahead and try this next one on your own. Okay, this time the graph is we're reflecting across the line y equals negative x. All right, so make sure you understand what that means and be able to graph that line correctly. So take a moment, go ahead and graph out those 3 points, graph the line y equals x, and then see if you can find those new points, and then come back and see how you did. All right, welcome back. I have went ahead and graphed my original triangle, GHI, there we go. And we're going to reflect across the line y equals -1. Now, again, like the last problem, we have all the information here that we need. It's just not shown. So we have the y-intercept, which is 0. As you can see, the graph has y-intercept of 0. And the slope of -1, and I've graphed that out as well. Now, to understand the reflection here, I'm going to figure out the perpendicular distance to that line and then echo it or equal it on the other side. So if I do that, up 1, 2, 3, 4, 1, 2, 3, 4. Okay, now maybe I should have made a comment here. What is the perpendicular slope? Well, if this is the original slope, okay, the perpendicular slope to that is going to be the opposite, so positive, and then the reciprocal, well, it stays just 1. So that's the slope up 1/1 in the positive manner. So 1, 2, 3, 4, 1, 2, 3, 4. Got it. Okay, G, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There's G prime. And then H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and then there's H prime. Okay. Now, I've been telling you guys all along that this is a form of rigid motion. These figures are congruent. With these right triangles, we can actually go ahead and prove it. Obviously, we have right angles there, but if I count the length of H and G, 1, 2, 3, 4, H to G, 1, 2, 3, 4, and then G to I, 1, 2, 3, 1, 2, 3. Well, we have side angle side there, so we know that the two triangles are going to be congruent, okay? But I do want to get to writing the rule, and if you've already done that, I don't want to hold you back. So here we go. For I, we're at 1, 1, 2, 3. Okay. For G, we're at 1, 1, 2, 3, 4, 5, 6. Okay. And then for H, well, let's make a guess here. If we're going from -6, -1 to 1, 6, it looks like that we're flipping the x and y value, and we're making them the opposite number. So if I flip, I get -5, -6, and then I want to make them both the opposite value, so I'm going to make them 5, 6. And let's just see if that works out there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, and it does. Bingo. All right. So how am I going to write this rule? I'm going to go ahead and write my original pre-image is there, and then we're flip-flopping those. So I'm going to put y and x, but not only we're flip-flopping them, we're changing their signs. Now, how do we change their signs? Well, I know that we're going from all negatives over here to all positives over here, so this kind of probably does this an injustice because it's going to look awkward or isn't going to seem right. But if you're going to go from an x here to the opposite x over here, you're going to have to put a negative in there, okay? And if you're going to go from a y here to the opposite y over here, we're going to have to put a negative in there. So let's think about this. If I plug in 3 here, and I'm moving it to the y, if I make it -3, that becomes +3. So I know that was kind of wordy, but I hope that made sense to you guys. That's how the rule should be stated there. All right, so I have, let me count them up here just to make sure I don't want to, I've got about 11 different examples there that I'd like you to go ahead and work out for me. I want to actually work out the first couple with you guys to make sure you've got these down. So let's actually go ahead and take a look at numbers 1, 2, and 3 just to make sure we've got this down. Now, each one of these is a different way to write the rule that's transpiring. In what I'm talking about is, this is a reflection, this is the reflecting line, okay, x equals 1, and then this is what they want you to reflect. So if I go to number 1, and I have point Q, I want to reflect this across the line x equals 1. X equals 1 is this line right here. So to reflect it across it, 1, 2, 1, 2, this point right here is the point that you want to describe. So it would be negative 1, negative 2. That's what I'm going to write down for my answer. If I was to reflect point Q across this line, this is where that point would lie. Okay? For the next one, I'll just go ahead and clear that completely off. We have a reflection across the line y equals negative 1 for point P. Well, let me locate y equals negative 1 first. Y negative 1, that's the line that we want to reflect across. Point P is up here, so the reflection is going to be 1, 2, 3, 1, 2, 3. That's the point that I want to describe. Negative 1, negative 1, 2, 3, 4. Negative 1, negative 4 is the point that would be formed from that reflection right there, okay? And let's do, well, you know what? I think you've got a good enough understanding now. This might be a little tricky, but think about what we did here and apply it to this right here. I think you can figure it out. So go ahead and do the rest of those problems for me, and then we'll check them in class. So I'll talk to you later. I hope you guys have a great evening. Good night.